Hello students, this is Dr. Ways and welcome to your lecture on the organs of the GI tract. We'll start by reminding ourselves about the peritoneum and the peritoneal membrane that lines the abdominal cavity. Remember, it's that double layered membrane that's surrounding both the wall of the abdominal cavity, which we discussed in the previous lecture, as well as the organs of the abdominal cavity, which we'll be discussing this lecture. So we remember the greater omentum here between the liver and the stomach, the omental bursa between the peritoneum and the organs that are surrounding it, the transverse mesocolon, the greater sac here around the small intestines, the mesentery that's surrounding the small, or that's holding together the small intestines and contains the blood vessels that supply blood and take blood away from those organs, and the greater omentum, which is that fatty apron or that fatty drape that covers the small intestines and can be reflected backwards during dissection. And again, another reminder that when we're talking about the peritoneum, we have the visceral that is attached directly to the organ, and the parietal, which is attached to the wall, in this case the abdominal wall. Here we see images of the peritoneum looking at it from a transverse section. So this picture would be the artistic rendition. This would be an actual CT of the abdominal cavity. And I want you to notice, because when you get to your imaging class, and what you should be able to do by the end of your didactic education is be able to identify organs within a picture, such as this CT scan right here. So you're not going to be able to see the actual peritoneum on these CT scans, but you can see the liver right here. You can see the stomach right here. We can see the spleen over here, the left kidney right here. You can't really see the right kidney yet, probably because we're not down far enough. And you can see some other structures such as the aorta here. You know, it's nice and round and large. The inferior vena cava, which is flat, more of a flattened shape because veins tend to be a little more floppy than arteries are. And of course, looking at it, this would be the anterior and the posterior, and you know this because you see the body of the vertebrae, the transverse processes, and a spinous process, which is always pointing posteriorly. But some things to point out in the cartoon here within this picture are the omental bursa. Remember, we talked about that as that space that's between the peritoneum and the organs. Excuse me. On the posterior abdominal wall, or near the posterior abdominal wall. We can see the lesser omentum here. Okay, notice that's between the stomach and the liver. And we also see what's called the falciform ligament. And even though we haven't gone over that yet, that is a ligament that helps the liver stay attached to the peritoneal membrane and thus the abdominal wall. The other thing we want to take note here is the retroperitoneal organs. All right, retroperitoneal means retro, behind the peritoneum. So if this is the peritoneum right here, let's do that in blue. This is the peritoneum right here. Then retroperitoneum is everything that is behind that peritoneal cavity. So it's technically not inside the abdominal cavity, it is outside the peritoneum of the abdominal cavity. And the organs that would be included in that would be the duodenum, which we cannot see in this image, the ascending colon, which we cannot see in this image. So the duodenum, which is the first part of the small intestine coming out of the stomach, is pinned down behind the peritoneum. So is the ascending and descending colon pinned down behind the peritoneum. So they're not just flopping around within your abdominal cavity, they're secured behind the peritoneum. The pancreas, which we can't see in this picture either. The aorta and the vena cava, which is aorta right here, vena cava right here, we've already discussed. And the kidneys and ureters, right here, the kidneys right here, and the ureters would be below this plane, going down into the pelvic cavity to the urinary bladder. So all of those are what we call retroperitoneal. They're still in the abdomen, but they are behind the peritoneum, therefore not in the abdominal cavity proper. Okay, another picture of the peritoneum, specifically the greater omentum right here. Okay, remember we talked about that as being a fatty drape that covers the small intestines. So you see that most of the small intestines here are covered by that drape. And during a dissection, you can reflect that back over so that you can see all of the abdominal contents that are underneath it. Notice that it sits at a level below the stomach and the liver and goes down about 2/3 of the way across the small intestines, but that's going to vary from person to person. Here, up above, we've taken away the rib cage, and we see the lesser omentum right here, between the lesser curvature of the stomach and the liver right here. And then we have this structure called, this opening called the epiploic foramen of Winslow. Foramen Winslow, or epiploic foramen. And epiploic simply means omentum. It's just another word for it. So that's the opening to the omental bursa. Another way to think about it is that your greater sac that we talked about would be out here, and your lesser sac would be behind the lesser omentum. So it's also a passageway between the greater sac and the omental bursa. All right, continuing with the peritoneum, we see the transverse mesocolon, or the here would be the root where it's actually originates, and that is responsible for attaching the transverse colon, which would go in this direction right here. Here would be the ascending, here would be the descending, and remember those are retroperitoneal. But the transverse mesocolon, or the transverse colon, is not, so it's held in place by this transverse mesocolon. All right, the sigmoid colon, which would come like this, is also not retroperitoneal, but is attached to the posterior abdominal wall by what's referred to as a sigmoid mesocolon, same kind of function as the transverse mesocolon. And then, of course, here we see the root of the mesentery, where the mesentery is actually coming from that double layer, folds back on itself, and extends across the abdominal wall and the organs of the abdominal cavity. All right, the arteries of the abdomen. We've gone over this slightly before, but this is something that you're going to have to know, and what I would recommend is on a piece of paper, taking and drawing it as you're going along so that you can remember what a map of it looks like. That way when you go to, let's say, the anatomage table, or you go to images, you can actually understand where they are because you have a good picture that you've physically drawn yourself of it. All right, so at the top here we have the celiac trunk, all right, coming directly off the aorta, the abdominal aorta, and that's that big structure right here. I'm going to erase that. And then just below that we have our suprarenal arteries. All right, so these are going to be arteries that go to the adrenal glands, and we'll talk more about that when we get to the adrenal glands. We have our left and right renal arteries. Okay, just below that. And then right at the level where the renal arteries are, you're going to have the next branch coming off the aorta, running right down the sagittal line of the abdominal aorta, known as the superior mesenteric artery. All right, and we'll talk about where that goes, what it supplies in the abdominal cavity. Just below that, we have our gonadal arteries. All right, in females it would be the ovarian arteries, in males it would be the testicular arteries. So those will go all the way down to their appropriate locations. We have the inferior mesenteric artery right here, and notice that that is branching out. All of these, in fact, branch out, and we'll get to the branches later on. And then the aorta branches into the lower limbs, starting with the common iliac arteries. All right, and then we have one artery coming off called the median sacral artery going right down the middle of the sacrum, hence the name median sacral artery. All right, so those are the big ones you have to know. Those are the main trunks that you'll be responsible for coming off of the abdominal aorta. Now what we'll do as we go along, we will focus in on each one of those and talk about where they go, what specific organs they supply, and what the specific branches are for some of them. But just as a preview, we can look here and see that the celiac trunk goes to the foregut. When we talk about foregut, we're talking about anything that is proximal alimentary canal versus distal alimentary canal. So, as food moves down the tube, the first place it goes would be proximal, the last place it goes would be distal. So abdominal foregut would be proximal, abdominal midgut would be in the middle, so that's where your superior mesenteric artery is going to go. Your inferior mesenteric to the abdominal hindgut. So right away we see, basically stomach, small intestines, large intestines, but we'll talk more specifically about that when we get there later. Suprarenal arteries go to suprarenal glands. Renal arteries go to kidneys. We talked about that. These phrenic arteries we talked about, inferior phrenic arteries, go to the diaphragm, which is the superior border of the abdominal wall, and the posterior superior border of the abdominal wall. And then the median sacral and common iliac arteries go to the lower limb. So we're not going to discuss those in too much detail. In fact, we're not going to discuss them at all during this lecture. All right, so let's start with the stomach. All right. First of all, going into the stomach, we have the esophagus. And remember, the esophagus goes through the diaphragm at thoracic vertebrae 10, just slightly left to the midline of the diaphragm, and enters into the abdominal cavity, and there it's called the abdominal esophagus. All right. And as the esophagus is entering into the stomach, we call that the cardiac region, or the cardia of the stomach. So it's just one little spot where the esophagus is entering the stomach. The main portion of the stomach is called the body of the stomach, and that's going to comprise the largest segment of it. Above that, the fundus of the stomach. All right, and that's typically where air can get trapped or will get trapped, and you'll be able to see that on an x-ray or other imaging techniques. And then just before you exit the stomach, we have something called the pyloric region, or the pylorus, and that is composed of the pyloric antrum, which is basically the entrance to the pylorus, the pyloric canal, and then the pyloric sphincter right here, which is a ring of muscle that controls how much and how often digested food materials exit the stomach and into the duodenum of the small intestine, which is the first part of the small intestine you'll get into. All right, we talked about the fact that the arterial supply for the stomach comes from the celiac trunk. Remember, the celiac trunk supplies the foregut, so the abdominal esophagus and the stomach itself would be the what we consider the foregut, as well as the duodenum. All right, so all of this in this picture would be considered the foregut. Excuse me. So here's your celiac trunk. All right, notice how small the celiac trunk is in terms of length. It's very short, and that's because almost immediately it branches into different segments that we'll have to know. And again, this is where it's going to be really important that you make drawings of the branches of the celiac trunk to help you remember what they are. So make your own drawings, own it, and find your best way to understand what the arteries are. So we're going to see it here, and I'll go through them, and we're also going to see it in the anatomage table, so you'll be able to get several different areas of exposure to these vessels. All right, so coming off the celiac trunk, we'll go to the right side. We have our common hepatic artery, which is this right here. It's not labeled on this picture, but that would be the common hepatic artery. And then you see this branch, the first branch coming off right here. That is our gastroduodenal artery. So that tells you that it's going to the stomach and to the duodenum. All right, after that branch, this large section is now called the hepatic artery proper. So instead of common hepatic, it's a hepatic artery proper, which then will branch off into your right and left hepatic arteries. And this other branch that's between the gastroduodenal artery and the common hepatic artery is the right gastric artery. So you see this right gastric artery coming around and going along the lesser curvature of the stomach. Okay, and just for reference, this would be the greater curvature of the stomach. Coming off the left side, we have our left gastric artery. Of course, that's going to go to the stomach as well. And you notice that it's connected to where it's coming from the right gastric artery. So there's an anastomosis there. And then the other branch coming off, which is wiggly back here, is the splenic artery, which, as you see, will go off in this direction to the spleen, but then it also has branches that continue to go to the stomach as well. So we have these short gastric arteries. And then the other branch is called the left gastro-omental artery. So that's going to go to the stomach as well as the omentum. All right, and then over here, where it's on the right side of the stomach, we call it the right gastro-omental artery. So on the inferior side of the stomach, which we would have our gastro-omental arteries. If it's on the right side, it's the right gastro-omental. If it's on the left side, it's the left gastro-omental. And notice that they are connected to each other. One thing I forgot to mention in this is that when we have the esophagus going into the stomach at the cardiac region, we also have a ring of muscle here, which is referred to as our lower esophageal sphincter, which controls food entering the stomach from the esophagus. And it's often when this is weakened that we have stomach contents refluxing back into the esophagus in a condition that we call gastric reflux. So clearly the importing of this picture was a complete failure, and I apologize for that. So make sure you pay attention to the larger picture on your PowerPoint slides that actually give you the labels that I want you to know. But I'll also write them in on this picture here. So here's your stomach, and remember this is the antrum of the pyloric antrum, and then this would be the pyloric canal, and then this is where your pyloric sphincter would be, right here. All right, so then you'd be entering into your duodenum proper, and the duodenum is divided into three parts. Let me erase this right here. Divided into three parts. The superior part, which goes from about right here to right here. The descending part, which would go from right here to about right here. And then the inferior part, which will go to about right here. But then technically there's also a fourth part which enters into the jejunum, and that would be the ascending part right here. So 1, 2, 3, technically 4 sections of the duodenum, starting with the superior part and going all the way around to the ascending part. Okay, and the entire length of the duodenum is about 7 centimeters, so it's not a very long section of the small intestine, but it is very important because the small intestine, or the duodenum of the small intestine, is where a lot of your digestive juices get squirted into from the liver and from the pancreas and gallbladder. So it plays a very important role in chemical digestion before absorption can occur. Notice also that the pylorus of the stomach and the duodenum sit between the celiac artery and the superior mesenteric artery, loop around in a C shape, and then come back around underneath the superior mesenteric artery to then become the jejunum. And of course, right here we see the gastroduodenal artery branching off to give blood supply to the duodenum as well as part of the stomach, the pyloric region of the stomach. The jejunum is the next section of small intestine, and it is the takes up 2/5 of the length of the rest of the small intestine after the duodenum. The term jejunum itself means empty. That's because most of your absorption takes place in the jejunum, so that when it's opened by anatomists or surgeons, it appears as if it's empty. And you'll find the jejunum, if we take a line right here and divide the abdominal cavity up into a oblique section, the jejunum would be in pretty much the left upper quadrant, all right, which is where you'd find the most of the jejunum. In contrast, you'll find the ileum, which is the last 3/5 of the remaining small intestine after the duodenum, you will find in the right lower quadrant. All right, so jejunum in the left upper quadrant, ileum in the right lower quadrant. And notice that these parts of the small intestine are highly folded, so they can occupy a much smaller space within the abdominal cavity. And because of its length, which is approximately 6 to 7 meters, it will take a while for chemically digested food to traverse the length of it, and while it's and it's going to move very slowly, so that will help aid in absorption. If we look at a radiograph of the small intestine, we notice that we can see a clear dividing line between where the jejunum is and where the ileum is. And notice that, again, like I drew the picture over here, the jejunum is in the right upper quadrant, whereas the ileum is in the right lower quadrant. Another thing to note is that the ileum, being the last part of the small intestine before you enter in the large intestine, ends right here. All right, and so where it ends, we have this valve called the ileocecal valve, which controls digested material, which controls materials that were not digested entry into the large intestine. So the ileum part comes from the ileum of the small intestine. The cecal part comes from the cecum, which is this pouch on the opposite side of the large intestine that the undigested material is going to travel and form fecal matter. And coming off of that cecum, you have the vermiform appendix. All right, so where the ileum enters into the colon, you have the cecum, which is a pouch, and the appendix coming right off that pouch. For the blood supply of the jejunum and ileum, notice that the branches are coming directly off the superior mesenteric artery. Remember, this superior mesenteric artery supplied blood to the midgut, so what we would consider the midgut would be the small intestines, as well as the proximal part of the large intestine. So branches off of that, we have the jejunal arteries, which are long loops that connect to each other, and then have branches that go into various sections of the jejunum, which are called vasa recta, if we look in this picture over here. And when we get to the ileum, of course this is not drawn to scale, When we get to the ileum, these loops tend to shorten, and then the arterial arcades and vasa recta become a little more complex, if you will, more complex in the ileum than in the jejunum. And then coming off of that, so those would be ileal arteries. So jejunal arteries, long loops, ileal arteries, smaller loops with a more complex vasa recta. And then we will have colic arteries coming off. Colic artery, of course, referring to the colon. We have the ileocolic artery, which would supply the ileum, distal ileum itself, and the proximal colon. The right colic artery, which would supply the ascending colon, and then the middle colic artery, which would apply the proximal end of the transverse colon with blood. As far as venous return goes, we have, and remember, all of these blood vessels are buried within the mesentery, including the arteries we saw on the previous page. And they all will coalesce to form this superior mesenteric vein, which will then head up towards the hepatic portal vein. All right, so that's important to know because as food is digested and absorbed by the small intestine, it enters these blood vessels, and before it heads back to the heart to be circulated to the lungs and then back out to the body, it goes through the liver in order to be processed, and that's through that hepatic portal vein and the portal system, so that all the blood that has just had food stuff absorbed into it goes to the liver, so the liver can decide what happens to that blood, and then the liver will pop it back out into the hepatic veins, which will then head back to the heart. All right, so here's a stylized version of what that looks like, coming from the small intestines. Hepatic portal vein goes all through the liver, comes back with the hepatic vein, and then heads back to the heart. A little more detail about the ileum and cecum. All right, so here's your ileum here, the last part of the small intestine, the distal part of the ileum that enters the large intestine. Here would be flaps that are part of the ileocecal valve. All right, and remember the ileocecal valve is a muscular ring that controls entry of materials from the ileum into the cecum. And here's that pouch that we talked about, the cecum. Notice that's on the opposite side from which material should be flowing in the intestine, so kind of like a little collection area. And then we have the appendix coming off of that. If we look in an image of a colonoscopy, we can see that here would be the cecum right here. So we're coming in this direction right here. We see the cecum here, and right here we would see the ileocecal valve, and coming from here would be the ileum. So contents would dump into here and then start heading in the plane that is coming towards us out of the screen. And then again, just to remind you that the superior mesenteric artery supplies blood to this area, and it's going to supply it through the ileocolic artery, again going to the ileum and then going to the most proximal part of the colon. I apologize for another picture that got left out. So this whole picture, if you look in your PowerPoint slide, should be right here. But basically it's showing you the colon that is without the any other organs in the way. All right, so I'm going to mostly show you over on this picture right here what's going on. So if we look at where the ileum and the cecum come together, that will be in the umbilical region, the right portion of the umbilical region in the abdominal regions. And then the ascending colon would be in the right flank region, all right, heading upwards until it comes to a spot where it bends just underneath the liver, all right, and notice that that's underneath the ribs. And of course, this is where it's going to go retroperitoneal as well. So this area right here, where we see kind of a bend, is called the right colic flexure. The right colic flexure. And flexure just means a bend. All right, and then it's going to go the transverse colon from the right side to the left side, and it's going to go all the way up near the spleen here. Excuse me, near the spleen here, and then bend in what we call the left colic flexure. Pretend that says flexure. Okay, and the left colic flexure is going to be in the left hypochondrium. The right colic flexure is going to be in the right hypochondrium, and the most of the transverse colon is going to head across the epigastric area. And remember, that's held in place, not retroperitoneal, but by the transverse mesocolon. And then you head down the descending colon, which again will be retroperitoneal, starting with this near this left colic flexure, downward, and then it's going to hit the sigmoid colon. Sigmoid is Greek for S, so it's going to have this curvy S appearance. All right, and remember, as you're coming out of the descending and going into the sigmoid, you exit a retroperitoneal, and so the sigmoid colon is held in place by the sigmoid mesocolon, and then we head into the rectum, and then finally at the end we head into the anus. Now, one thing you should be familiar with, and I think we might talk about this in physiology as well, is that as contents coming from the ileum head into the colon, one of the colon's primary jobs, primary jobs, is to absorb water as well as to form feces. All right, so everything coming in right here to the ileum, from the ileum to the cecum, is going to be very liquidy. All right, so as contents travel upwards in the colon, water is going to be absorbed, and so by the time it reaches a transverse colon, so this is going to be very watery. By the time it hits the transverse colon, you're going to have more of a pasty kind of texture to the fecal matter. And then as water continues to be absorbed, once you get down from the left colic flexure heading into the descending colon, here is where you start to have more solid fecal matter, which is then going to travel through the sigmoid colon and then out the rectum and the anus. So again, this is just showing you the ascending colon, the right colic flexure, and remember that's going to be in the right hypochondriac region. The transverse colon moving up into the left colic flexure. Notice that it's right near the spleen, so it's going to terminate where the spleen is and then come right back down into the descending colon, and that's going to be your left colic flexure. And if we look at it as a whole, notice that it is completely surrounding the outside of the small intestines, and the small intestines are kind of bunched in between the tracts of the large intestine. All right, and then of course we have the sigmoid colon, and again here, remember, fecal matter should be solid. And then we have our rectum, which is kind of a holding area for fecal matter until we get the signal from stretching, sends signals up to the brain that then come down and open the internal anal sphincter to produce a defecation reflex. Of course, we do have an external anal sphincter, which we can consciously control and hold it in until we can get to the bathroom to void properly. All right, and then of course when we void, it's going to come out the anal canal. Looking at the blood supply to the colon, for the right side of the colon, which will include the ileum, the cecum, the ascending colon, and the proximal portion of the transverse colon. That's going to be supplied by the superior mesenteric artery. The distal transverse colon, descending colon, sigmoid colon, and rectum is going to be supplied by the inferior mesenteric artery, and all of that's going to be on the left side. So the right side, still considered somewhat midgut, the superior mesenteric artery, left side inferior mesenteric artery, and remember the inferior mesenteric artery supplies the hindgut. All right, so that would be everything that you are trying to get rid of that was not absorbed by the digestive system. So descending colon, sigmoid, and rectum and anus. Actually, the anus does not have a blood supply coming from the inferior mesenteric artery, and we'll see that in a little bit. Now we'll talk specifically about the rectum and anal canal. So the rectum is this area right here, right after the sigmoid colon, and then the anal canal would be the last part that's actually coming out of the body. And so here you see another view of the rectum, and notice that it is an enlarged area, so it can store feces until they're ready to be voided. And then the rectum right here, notice it has a different structure. So one of the first things I want to point out are these blood vessels on either side, these veins that are very close to the surface of the wall of the rectum. And when people get hemorrhoids, it's these blood vessels that are the ones affected. Just outside of those blood vessels, or surrounding those blood vessels rather, you'll see the internal anal sphincter, right? The internal anal sphincter, and that one is under involuntary control. So it's a parasympathetic nervous system that causes those muscles to relax and aid in the voiding of feces when stretch is detected in the rectum. Just outside of that, or surrounding the internal anal sphincter, we have the external anal sphincter, and that is skeletal muscle, which is under voluntary control. So if the internal anal sphincter is relaxing and you have that feeling like you have to defecate, then you can consciously contract the external anal sphincter so that we can hold that that fecal matter in until we get to a spot where we can defecate in a place of choice. All right, outside of that, we have the skin. All right, so this would be actual skin in the perianal area, what we refer to as the anal margin. And the anal verge here represents the distinction between the external anus and what becomes the internal anus. And then we have this dentate line with the transitional zone, which marks the transition from epithelial tissue to more of a mucosal tissue that is consistent with the lining of the rest of the digestive tract and will do similar sorts of things like secreting mucus and so on. What this dentate line also marks is the line where you would see external hemorrhoids versus internal hemorrhoids. So anything above that line or deep to that line would be an internal hemorrhoid, and anything superficial to that line or below that line would be an external hemorrhoid. In addition, the external side of the dentate line tends to be more sensitive than the internal portion of the dentate line. So anything in this direction is less sensitive, and anything in this direction is more sensitive when we're talking about cutaneous sensations. As far as the blood supply goes to the rectum and anus, remember I said it was a little bit different than the rest of the alimentary canal in terms of the colon and the small intestine. The superior rectal artery is a branch off of the inferior mesenteric artery, so that kind of lines up with everything else. But the inferior rectal artery and middle rectal artery that supply the distal rectum, moving towards the anus, is supplied by the branches from the right common iliac artery and the left common iliac artery. So notice that these are different spots than coming from the inferior mesenteric artery. Okay, so a brief review of the blood vessels that are in the abdominal cavity that supply the abdominal organs. First, we have the celiac trunk. Below that, we have the superior mesenteric artery, the left and right renal arteries, and of course the suprarenal arteries would be in here as well. And then we have the left, right, and left gonadal arteries, and then we have the inferior mesenteric arteries, and here's our common iliac arteries as we saw in the previous slide. That the internal iliac artery from the common iliac would supply the rectum and anus with blood. All right, and this is a nice picture that shows you the celiac trunk, and well, actually the order in which these go from top to bottom, and the fact that the celiac trunk supplies the liver with blood, it supplies the stomach with blood, it supplies the spleen, as well as the pancreas, although we didn't cover the pancreas specifically, and the duodenum. The superior mesenteric artery covers the jejunum, covers the ileum, and covers the proximal colon, whereas the inferior mesenteric artery covers the distal colon, as well as the proximal portion of the rectum. All right, so again, there's one of these slides which is missing an entire picture up top here, which is showing you the gastroduodenal artery and the supraduodenal artery in a close-up picture of the duodenum and its relationship to the aorta, inferior vena cava, and the gallbladder and liver. All right, so I can't go over that one here, but it's a simple enough picture. On this image, we see of course, the celiac trunk, and that branches off into the left gastric artery. And notice that the left gastric artery also has esophageal branches. So it's that left gastric artery that is supplying the abdominal esophagus with its blood. Then, of course, we have the splenic artery, wavy, coming over here to the spleen. All right, and this is a spleen situated right to the side and just behind the stomach, or just lateral and posterior to the stomach. And notice that that is also deep to the ribs. All right, so the spleen is protected. So when you get to physical exam and you're actually feeling for the spleen, usually you won't feel it because it's tucked way up under there. But if you do feel it, you'll feel it in this area, and only because it has been enlarged or it's out of place for some reason. All right, but that splenic artery also branches off into short gastric arteries, which supply the fundic region of the stomach with a blood supply. All right, continuing with the left gastroomental artery coming as a branch off the splenic artery, which meets up with the right gastroomental artery, which is coming off as a branch from the gastroduodenal artery right here. All right, and so the gastroduodenal artery is coming off of, let's go back, celiac trunk, and then we have our common hepatic artery. Then we have our gastroduodenal artery, which then goes into the right gastroomental artery. The next branch, the right gastric artery, coming off here, going to the stomach. Remember, that goes along the lesser curvature and meets up with the left gastric artery. And then we have the hepatic artery proper, which is just this small segment right here, which then branches off into the right hepatic artery and the left hepatic artery. All right, and down here we see the superior mesenteric artery, all right, and the celiac trunk. And notice that the pancreas, much like the duodenum and the pyloric region of the stomach, passes between the celiac trunk and the superior mesenteric artery. So here's another view of your gastroduodenal artery as it branches into the posterior superior pancreatico-duodenal artery. All right, so notice that's supplying both the duodenum and the pancreas, as well as the anterior superior pancreatico-duodenal artery. It's right here. Okay, supplying both the pancreas and the duodenum with the blood supply. And then it joins right here with the inferior pancreatico-duodenal artery, and then to the superior mesenteric artery. So if you notice, there are a lot of redundancies in circulation to the digestive system, and that's important because if any of these get blocked, we want to have a redundant system that is able to keep blood supply going to those organs to keep them alive. All right, and I don't think in your list for the anatomage table, your anatomy lab, you have to find all of these specific ones, but I want you to be aware that this gastroduodenal artery does branch off into branches that go to the stomach, duodenum, as well as the pancreas, who sits right in that same region. I always tell students that the pancreas sits right in that C-shaped loop of the duodenum, and indeed, if you consider the duodenum as having a C shape, that pancreas sits right there, and that makes sense because of pancreas's function in relation to the duodenum. All right, so moving on to the superior mesenteric artery. Remember that it supplies the jejunum, it supplies the ileum, and it also supplies the proximal portion, ascending, and the very beginning of the transverse colon. And of course, we see that again occurring right here. Here's your superior mesenteric artery right here. Here's your inferior mesenteric artery, and the superior mesenteric artery going to your proximal colon right here, as well as your ileum. Okay, and then your inferior mesenteric artery goes to the distal colon, the descending colon, sigmoid colon, and then the proximal portion of the rectum. And remember, the distal portion of the rectum and the anus comes from the internal iliac artery, branches from the internal iliac arteries. All right, then again, another picture. I always think you can never have too many pictures. The superior mesenteric artery and the organs that it supplies. And again, this should be standard now. Superior mesenteric, all of the small intestines except the duodenum, and then the proximal portion of the large intestine, whereas the inferior mesenteric artery, again, the distal portion of the large intestine, sigmoid colon, and proximal rectum. And that is it for the organs of the digestive system. Next, we will cover the accessory organs to the digestive system. So the liver, the gallbladder, the pancreas, and how they relate to the function of the what we term the alimentary canal.